Alright, welcome back everyone. This week we're just going to do some more examples of scientific notation. So just remember, if you have a large number, you're going to move the decimal to the left until it's behind the first number, and then we're just going to count the number of places the decimal was moved, and that's the exponent that you're going to use. Here we have a large number, so the exponent is positive. If we have a small number, we're going to move the decimal to the right until it's behind the first non-zero digit. Count the number of places we move the decimal. This is our exponent, and then here the exponent will be negative because it's a small number. So if we want to write this number in scientific notation, the decimal point is here at the end. We're just going to move this 1, 2, 3, 4, 5, 6, 7, 8 until it's behind the first number. 4.651 times 10 to the positive 8. To write this number in scientific notation, same thing. Our decimal point is here at the end. We're going to move 1, 2, 3, 4, 5, 6 places. So we get negative 6.4 times 10 to the positive, because it's still a big number, it's just negative. 10 to the positive 1, 2, 3, 4, 5, 6. If we want to write this number in scientific notation now, since it's a small number, we want to move this to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And we get 6.5 times 10 to the minus 9. Because this is a really small number, we get a negative exponent. If we want to write this number in scientific notation, again, we're just going to move 1, 2, 3, 4, 5 places to the right. And we get 2.1 times 10 to the minus 5. If we want to convert to standard notation, we just move the decimal in the opposite direction. 2.36. We want to move 5 places to the right. 1, 2, 3, 4, 5. And then we're just going to fill in any empty space with zeros. And so this is 236,000. If we want to write this in standard notation, just as a number, 9.1 times 10 to the 11th, well, that's 9.1. We're going to move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places, and we're just going to fill in zeros all through the number. And so 9, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And then we can just put the commas, 910 billion. Again, if we want to write this in standard notation, now we have a negative exponent, so we're going to go in the opposite direction. I'm just going to move the negative over here for a minute. 1.79. We're going to move 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7 zeros. So negative 0.123, 4, 5, 6, 7 zeros, and then 179. To convert 6.646 times 10 to the minus 6 into standard notation, we're again just going to move the decimal point 6 places to the left. 1, 2, 3, 4, 5, 6. And then fill in our zeros. 0.12345 zeros, 6646. Finally, scientific notation looks a little different on a calculator or in Excel. So in Excel, they'll use a capital E instead of times 10. So if we have the Excel output that you see here, we want to write this in standard form. Well, this is the same thing as 1.2356 times 10 to the positive 10. And so 1.2356, we're going to move the decimal point 10 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then just fill in the zeros. 1, 2, 3, 5, 6, and then 6 zeros. To do the same thing again, 2.54 e to the plus 8 is the same thing as 2.54 times 10 to the 8th. We're just going to move the decimal point 8 places with 1, 2, 3, 4, 5, 6, 7, 8. and add zeros. 254 with 6 zeros for 254 million. Finally, we have 9.237 times 10 to the minus 7. We want to take and move our decimal point 7 places to the left. 1, 2, 3, 4, 5, 6, 7. And then just fill in zeros. This is 0.12345692337. Practice this in Excel and in your calculator, and please let me know if you have any questions.